So in this problem, we need to select whether the given value is or is not a solution to this algebraic inequality. And when we look at this inequality, 10 is greater than or equal to y, we get the inequality, and then we have a visual picture of the inequality. So we're going to use both pieces so you can see how you can check yourself in two ways to make sure you're selecting the correct solutions. Some are going to be easier to see than others. But it's good just to run through two ways you can do this. So we're going to start with 10 right here. And we're going to first substitute 10 into the inequality. So 10 is right here. I'm just going to rewrite it. And I want to say is greater than or equal to, and then I'm going to replace y with my number 10. And I'm going to read it left to right. Is 10 greater than or equal to 10? Well, it's not greater than 10, but it is equal. And we can see that that is true. So this is a solution based on just plugging it in. When we come over to the graph, we can see that 10 is a solution because they used a solid dot for that endpoint. That is the biggest number that y can come up to is 10. So the next one I'm going to check is y equals 90. So I'm going to write 10. I'll just use the right here. I'm going to write 10 is greater than or equal to, just keep that, and then I'm going to substitute in 90 this time for my y value. And then I'm going to read it left to right. Is 10 greater than or equal to 90? No, it's not. That doesn't make sense. 10 is not greater than 90, so we cross it out. It can't be a solution. 90 on the number line would be way up to the right of 10. But when we read this inequality, 10 is bigger than all my y values. My y values then are all to the left of that endpoint. And 90 is not to the left, it's to the right, which makes it greater. We want all the numbers that are smaller than 10. 10 is the biggest, 10 is the greatest. That's how this reads. So then we look at negative 9 3/4. So we can take that 90 out, put in negative 9 3/4. We do this for each just to read left to right, and it's nice if you write it because then you can see what you're reading. You don't have to manage it all in your head. 10 is greater than or equal to negative 9 3/4. Is 10 bigger than negative 9 3/4? Yes, 10 is bigger than all negative numbers, so that's an automatic win. If we go to the number line, negative 9 3/4 falls between negative 9 and negative 10, right about there. And that number is to the left of our endpoint like it's supposed to be because 10 is bigger than it. So that means this number falls in that proper side of 10. Okay, then the next one we're going to check is 0. Replace y with 0. 0 on the number line falls right there. 10 is greater than 0. Of course it is. And when you look here, 10 is bigger than 0 because it's further right of 0, so that makes that true as well, looking at the visual picture. The next one is 6. Again, probably not one you have to think too hard about, but you got to make sure you read left to right. 10 is greater than 6. Yes, it is. 6 is here, 10 is to the right of it, which makes 10 bigger than 6. Our next one, 10.01. 10.01, plug it in, 10, whoops, I'll just write it in again, keep erasing right. 10.01. 10 is greater than 10.01. So if we look at our number line, 10.01 is just to the right of that solid point, and numbers to the right are bigger. So that does not work. 10 is not bigger than 10.01 because 10.01 is to the right of it. So this fails that test. It's not a solution. And finally, 100. Is 10 greater than 100? 100's way over here on the number line somewhere. And 10 is to the left of that, which makes it smaller than 100, not bigger than 100, so that fails. And that's it. Those are your 4 solutions from the options you were given.